Good afternoon everyone. In the last lecture we have seen the arc welding, in which the process of arc welding, then what are the different equipments required for the arc welding, and the comparison between the AC and the DC welding we have seen. Today we are going to see different processes of the arc welding. These arc welding processes are commonly used, that are carbon arc welding, metal arc welding, metallic inert gas welding, which is called as also MIG arc welding, and tungsten inert gas, which is TIG arc welding, atomic hydrogen welding, stirred welding, submerged arc welding, plasma arc welding, flux core arc welding, electroslag welding, and electro gas welding. So one by one, all these arc welding processes we are going to see in this video. So the first one is carbon arc welding. In this carbon arc welding, the welding heat is obtained from the electric arc between a carbon electrode and the work. And the two parts to be joined, they are fused, as you can see in the diagram. And in welding the heavy plates, the additional metal is deposited in the weld from a filler rod. As you can see, the filler rod is also indicated in the diagram. In another method, which is also known as a twin carbon arc welding, two carbon electrodes are employed between which the arc is formed, and in this way the arc is generates the heat which is applied close to the part which are going to weld it, causing the edges to fuse. And in heavy welds, a filler rod is made by the arc and it deposited in the weld. The twin carbon arc welding is very similar to the gas welding we can say, in which the heat is generated above the work and is played upon it. The difference between the two are in the source of the heat and the differences in the atmosphere around the work. In case of this carbon arc welding, the current is of 20 to 800 ampere is used, which depends upon the thickness of the metal that we have to weld and the diameter of the electrode. And most of the carbon arc welding is done with the automatic welding equipments, where the arc voltage and the current, rate of travel and the rate of feeding is filled with the filler rod, and they are properly controlled. The carbon arc welding is used in all the modern industries for welding of the materials like cast iron, steel, copper, bronze, aluminium, and also for the rough cutting of the metals. So this is all about the carbon arc welding. Next one is the metal arc welding. The diagram is also provided for the metal arc welding. In this arc welding, the arc is produced between the metal electrode, which are also called as the filler rods, and the workpiece. During the welding process of the metal arc welding, the metal electrode is melted by the heat of the arc and it fuses with the workpiece. The temperature for the process produces the heat, which is about 2400 degrees Celsius to 2700 degrees Celsius. The electrode used in the process of metal arc welding, they are straight piece of metal wire which are about 25 centimeter long, and the diameter ranges from 1.5 to 10 mm. The basic setup for the metal arc welding you can see in the diagram. This metal arc welding, it is normally a manual process when the metal piece to be joined are relatively thick, and then the number of individual passes are required to complete the welding process. The welding process is not happen with only one pass. For that, multiple passes are required. And the line of metal deposited during the single pass, it is called as a bead. And by removing the electrode side to side, a wider bead may be obtained and more metal is deposited during the number of passes. So this is all about the metal arc welding. Next process is the metallic inert gas welding, which is also called as the MIG welding. See, in the metallic inert gas arc welding, which is commonly known as the MIG welding, this is similar to the tungsten inert gas arc welding that also we are going to see in the upcoming slides, except that the electrode is consumable in case of the MIG one. And in this process, the filler metal wire, which is around 0.75 mm to 1.5 mm in diameter, of the desired composition, it is automatically and continuously fed from the reel at the speed of from 250 to 750 centimeter per minute. It is continuous supply. The filler metal gets deposited by the arc, which is completely surrounded by the inert gas. And this process is used for the same application as that of the tungsten gas arc welding, but it is widely used for the welding thick plates above 4 mm in the thickness. And this process may be done either manually or with automatic equipments. See the schematic diagram for the MIG welding, as you can see here. The continuous supply of the electrode is which is as a filler, it is provided. Some of the advantages of the MIG welding are the variety of metals can be welded with this process, all position weldings can be done, and the quality of weld which we create, it is a good one, and little to no sweat, no spatters. And the disadvantages of MIG welding are the cost is very high, they are less portability. Less portability is found in case of the MIG welding. Outdoor welding process this is, and clean base material is necessary for this kind of welding process. Next one is the tungsten inert gas welding, which is also commonly known as a TIG welding. Here the heat is produced from the arc between the non-consumable tungsten electrode and the workpiece, and welding zone is shielded by the atmosphere of the inert gas such as helium or argon supplied from the suitable source, and a gas nozzle surrounds the tungsten electrode, as you can see in the diagram. When the gas leaves the nozzle, it completely envelops the tip of the electrode and the work under it. So in this process, either direct current or alternate current is used. The selection depends upon the type of metal that we are going to weld. And the direct current with the straight polarity is used for welding the copper alloy, stainless steel, whereas the reverse polarity is used for the magnesium. The alternating current is more versatile in this application, and it is used for steel, cast iron, magnesium, aluminium. This process is capable of making the weld in the aluminium without use of corrosive fluxes. Though any metal can be welded by this process, yet it is best suited for the welding of relatively thin piece of the metal. This TIG welding may be done either by manual process or maybe automatically like the MIG welding, and when it is manual, the welds can be made at any position. So there are also some advantages of this the TIG welding. The welds are welds more metal and metal alloys than the other process. Variety of metals can be joined with the help of the stick welding. High quality and precision is found in the TIG welding. Then pinpoint control can be done. Adhesive weld braids, no spark or spatter. There is no flux or slag and no smokes or fumes. So comparatively, we can say it is a clean process. And some of the disadvantages are like lower filler metal deposition rate. Good hand-eye coordination is required, so the skill level should be required for this kind of welding process. Brighter UV rays than other processes, so they may harm. Then slower travel speeds than other process, and the equipment cost, it is high comparative to other process. So these are some of the disadvantages of this process. In the next video, we will see the remaining processes of the arc